If you have ever flown on an airplane, you know that it's an enormous-sized, amazing machine. A typical 747 can carry more than 500 passengers and weighs around 800,000 pounds when taking off. Yet it rolls down the runway at a speed of 290 kilometers per hour and, as though by magic, lifts itself into the air and can travel up to 13,000 kilometers without stopping. Incredible, isn't it? Today, we are going to learn how an airplane flies in a very simple way by going through the aerodynamics of an airplane, the main parts of an airplane, and controlling the airplane. The aerodynamics of an airplane. The four aerodynamics of an airplane are drag, thrust, weight, and lift. Drag, also called air resistance, refers to the forces acting opposite to the relative motion of any object moving with respect to a surrounding fluid. The energy it takes to push through the surrounding fluid creates drag. You may have noticed an excellent example of drag reduction in track cycling. The cyclist must push through the mass of air in front, but a streamlined sitting posture that cuts through the air more smoothly enables a cyclist to travel much faster, with less effort. The airplane always retracts its landing gear and nose gear into the body of the plane after takeoff to reduce drag. Thrust counters drag. It is a mechanical force that keeps the airplane moving in the air. Thrust is generated by propellers, jet engines, or rockets. The compressor inside the jet engine takes the air and compresses it, and after processing from the combustion chamber and turbine, the gas is blown out through the exhaust nozzle. Here, Newton's third law of motion is applied, where the gas is pushed backward and the engine is pushed forward. Weight is the airplane body, passenger, and luggage weight in total. Lift overcomes the weight and holds the airplane in the air. Lift is created mostly by wings to keep the plane aloft. So, to keep the airplane moving, flying straight and level, this must be true, which means no net force acting upon an airplane. In any case, if drag is greater than thrust, the plane slows down. If thrust is greater than drag, the plane moves faster. If weight is greater than lift, the plane descends. If lift is greater than weight, the plane climbs. Parts of an airplane. The basic parts of an airplane are 1. Wings, 2. Horizontal stabilizer, and 3. Vertical stabilizer. The wing is the most important part of an airplane, since it produces lift that allows a plane to fly. A wing produces lift because of its slightly inclined and special shape, which is called an airfoil. This special shape is designed to deflect the air at the bottom of the wing due to more air strikes at the bottom and less air at the top of the wing. As the airplane rolls down the runway, higher pressure and more upward force produces below the wing, and lower pressure and lesser downward force above the wing. The net result is the lifting of an airplane. Stabilizer. Stability in an airplane is a tendency to return to its initial state after a disturbance from that state. Horizontal stabilizer performs this function when the disturbance force causes the nose of an airplane to move up or down. Such movement is called pitch. Vertical stabilizer provides stability for a disturbance in yaw. Yaw is side-to-side motion of the nose. Controlling the airplane. So what are the components in an airplane which control the flight, direction, and height, and maintain the equilibrium? It's elevator, rudder, and aileron. The elevator can be deflected up or down to produce a change in the downforce produced by the horizontal tail. If the elevator is deflected upward, it increases the downforce produced by the horizontal tail, causing the nose to pitch upward. If the elevator is deflected downward, then the counteracting force causes the nose to pitch down. The rudder can be deflected to either side to produce a change in the side force produced by the vertical tail. If the rudder is deflected towards the right, it creates a side force to the left, which causes the nose to yaw to the right. If the rudder is deflected towards the left, it creates a side force to the right, which causes the nose to yaw to the left. Ailerons are located on the tips of each wing. Ailerons can be used to generate a rolling motion for an aircraft. Ailerons usually work in opposition. If the right aileron is deflected upward, then left is deflected downward, and vice versa. Let's see this. To curve the flight path, the pilot deflects one wing to move up and the other wing to move down by controlling the ailerons. With the left aileron in downwards direction, the lift will increase, whereas at the same time, the aileron of the right wing is in the upward position. Therefore, lift on the right wing is decreased. The result will roll the aircraft to the right. If the pilot reverses the aileron deflection, right aileron down, left up, the right wing will lift up and the airplane will roll to the left. The next time you travel in an airplane, you'll know how it works.